Thank you everybody for joining us for our webinar today, which is Automating Your IT, presented by BossNine Technologies. My name is Colin White. I'm with BossNine Technologies. And before we get started on the presentation, I wanted to go through just a couple of housekeeping items. First of all, we are recording today's presentation, and we will be providing all attendees with a link to the recording afterwards, usually within about 24 hours after the presentation. So keep an eye out for that. Also, we'll be taking questions and answers at the end of the presentation. So if you have any questions over the course of the presentation, please feel free to use the Q&A, the Zoom Q&A box, which should be at the bottom of your screen. Just click there and enter questions at any time, and we will answer them all at the end of the presentation. So just a couple of quick introductions here. The bulk of today's presentation will be given by Mark Walker from Red Hat. He is the Red Hat Ready Program Solutions Architect. Mark is joined by Mike Beaton, who's a marketing resource manager at Red Hat. And today's webinar is sponsored by BossNine Technologies. So we're joined by Joe Fistori, who's the co-founder of BossNine. And without further ado, I'm going to pass it over to Joe.
Well, hello everyone, and thank you very much for attending. I think you'll really find this presentation informative. And today, so I'm the co-founder of BossNine Technologies, as Colin had noted. And today, this presentation will be really a two-part presentation. Mark and Mike will be addressing and discussing 4 foundational questions of automation in the first part. What is automation? Why do we automate? What do we automate? And when do we automate? And then Mark will take over and talk a lot about Ansible, Red Hat's premier automation solution. So at BossNine, we use Ansible exclusively with our customers. So we are a big MSP, a managed service provider, and Ansible is our solution of choice for automation for our customers. So what I'd like to do now is give a quick 30-second infomercial on BossNine so you know who we are, and then we can turn it over to Mike and Mark from Red Hat to get into the presentation. But thank you again for attending. We appreciate it. So quickly, BossNine Technologies was born as a public cloud professional service provider. So we provide things like cloud roadmaps, designs of cloud infrastructures, mapping on-prem to public clouds. We do cloud enablement, which is things like migrations to the cloud and also greenfield deployments of cloud. We do cloud optimization, things like re-architecting applications, microservices, containers, and DevOps. More, trying to get our customers' applications more cloud native to operate more efficiently in the cloud. And we also have a full practice of managed services for our customers that are now in the cloud and would like the expertise of a cloud service provider to help them manage their clouds. BossNine also owns, and we're proud to own, Pantech.com. Now, Pantech has been in business for 25 years as a Linux service provider. So Pantech provides Linux and open source experts for support services and projects. So the folks at Pantech have been working in the Linux kernel for 15 to 20 years. So they are the experts that you're looking for if you're working in the Linux world. They've done over 25,000 support cases, so a very seasoned team in the Linux world. With that, I'd like to turn it over to Mike Beaton and get the presentation started.
Hey, thanks, Joe. Hello, everybody. Thanks for coming today. My name is Mike Beaton. I am the Marketing Resource Manager here at Red Hat for the Red Hat Ready Partner Program, of which BossNine is a Red Hat Ready partner. If you're not familiar with Red Hat, we are a multinational open source software company founded in 1993. Some might say we are largely associated with our enterprise operating system, Red Hat Enterprise Linux, but we are actually much more than that, as you can kind of see here with the visual. We have a variety of products that solve each one of your pain points, whether it's in storage, virtualization, cloud, mobile, even middleware. We really pride ourselves on leveraging the open source community to continue to bring our customers, such as yourselves, bleeding edge products in a variety of different markets. As far as who's using our software, we have a pretty equal spread across multiple verticals globally. We feel very fortunate that the leaders in a variety of sectors are choosing to use Red Hat solutions to help run their businesses, whether it's 100% of the healthcare companies or 100% of the airlines, 100% of the commercial banks, 100% of the telcos, and 100% of the US exec departments in the Fortune 500. That's it for me. Enjoy the show. At this time, I'd like to introduce you to my colleague, Mark Walker, the Solutions Architect for the Red Hat Ready Partner Program. Mark?
Thanks, Mike. Thanks, Joe. Hi, guys. I'm Mark Walker. I'm the Red Hat Ready Partner Program Solutions Architect. I'm going to apologize ahead of time because I do tend to speak rather quickly. Just to give you an idea of my background, when I'm talking about the impacts of this on organizations and what you do, is I'm an enterprise architect and developer by trade. I've been in the business for 34 years, started on the mainframes and ended up doing container development using Golang and other services, and saw the growth and how the industry has changed literally over the last 3 decades. And it kind of gives me a unique insight into what I've seen happen in different organizations over time. And these are the things that are common, not just to you, but to every organization that has any type of IT that they try to manage themselves. And that's really what this conversation is about. So when we think about the challenge of running an information technology shop in whatever technology stack you're using, we have a lot of problems that we tend to have to deal with. And those problems involve doing a lot of things by hand. Having your administrators basically hand deploy new applications, new servers, making configuration changes, having your network administrators manually make changes to your firewalls, manually configure your networking switches, manually set up VLANs and VLAN overlays and all the other things that you're normally going to have to set up. And what that does is that basically means that you end up with a couple of huge problems. One is different servers that are supposed to be the same end up being different. Servers that are done one way change over time, what we call configuration drift, which means that you can no longer depend on that server working or behaving in the way that you actually expected. Errors being introduced because of those same manual activities, where maybe a junior tries to duplicate what a senior does, or maybe a senior is just doing it over and over again and changing one value from one server to the next as they try to automate or do processes across multiple servers or multiple containers or multiple VMs or whatever infrastructure they happen to be doing configuration on. And that means that things happen, and things happen that you can't debug, or things happen that work differently between machines. I've worked in DevOps for a long time and seen us deploy a server to one environment, say a testing environment, integration test, and then move it into system test and have it not work. Make a bunch of changes to get it to work there, get it into user acceptance testing, and again, have it not work. And not being able to repeat those things makes it very, very difficult to support infrastructures, makes it very, very difficult to sustain those infrastructures over time. And that's really a problem. And what we need to do is change this idea of having individual servers that need individual attention, what we call pets, where you have to treat every single server instance as its own individual thing with special care. We'd rather treat things as cattle, where it's just a matter of rolling everything out, treating it all the same way, essentially move to this whole new model of infrastructure as code, where I can basically run a script and no matter what, it's going to work in every environment, and no matter what, every environment that should be the same is the same and always stays the same. That's really the case for automation. It's how do we deal with these multiple silos that you have in an organization, where you have to be able to support infrastructure, say, running on Windows, infrastructure running on AIX, infrastructure running on Linux, maybe some legacy running on Solaris, maybe even some stuff in Unix or on ZOS, some of your infrastructure running on virtual machines in VMware or Hyper-V or in Amazon or on Google. Organizations are complex and they deal with a lot of complexity. And to make that all work, we end up having a bunch of steps. We have developers and administrators with one set of tools for one platform and people with different sets of tools for other platforms. We have to do all kinds of weird and wonderful things to make things work between these different systems. One of the last projects I worked on before I took over this role was literally a 3.5-year project to integrate and automate 300 server deploy of a huge server stack that across many platforms, and we ended up having to use a combination of Ruby with Puppet, KSH, Bash, just this huge monstrosity, and it made it very, very brittle and made it very, very hard to sustain over the long term. So we need to deal with all of that. We need to deal with finding people who have those skills, and we need to be able to make this all work and be successful at it as an IT organization. So when we are in that situation, what we have is this situation where we can look at the actual difference on the ground between organizations that have been successful at moving from a manual-oriented, siloed approach to their automation and how they manage and configure their infrastructure to an automated approach to manage and configure their infrastructure. And in essence, what it ends up happening is they get more control and more handle over things, where they can do more configuration management, more of their, in this case, we're actually talking about how much more they do. They do 33% more configuration management done with automation, 27% more of their testing is done with automation, and 30% more of their deployments with automation, and they can do more of their change approval process with automation. And what that results in are huge returns on, you really do get a lot back. So for those high performing organizations that meet that previous requirement I just discussed, they end up being able to deploy their code 46 more times frequently. So that means that I can be doing 4 or 5 deploys a day. That means I can be deploying into my environments continuously. That means I can be doing network changes, not at the end of the day in a tiny little 5-minute window where I don't want to break anything and I hope nothing goes down, to open a new firewall rule or make a firewall rule change, where I can actually do these kinds of changes more often, where I can actually have servers automatically lifecycled for me, so I don't have to worry about bringing them down, doing stuff where it's all done behind the scenes and all automated, where I can actually do way more times, way faster time to do my deployments, where I can do way faster time to recover. So when I do a deploy and it fails, I can get back to the old state much, much faster. I can still remember the times where it'd be Saturday night, we'd start a big rollover of a new application, we'd get all the teams involved, we'd be up all night till 6 o'clock in the morning, and then something would fail. And then we'd spend the next morning until 12 noon on a Saturday, or even sometimes later in the night on this, or the Sunday night, just trying to recover from what we did to try and push a rollout. Those times are gone. If you want to be able to survive, if you want to be able to return value to your customers, if you want to be able to allow your organization to adapt as quickly as the business needs it to, you need to change the way you do business, and the way you do that is with automation. So what it comes down to is, if you do automate and you do it successfully, you're going to end up spending 50% less time doing unnecessary redundant work. And it's going to give you 60%, 66% more time to do new things, to actually innovate, to come up with new ways to automate, or just to deliver new services and capabilities. And that's huge if you really want to be an adaptive, agile organization in this really, really fast-moving world that we're now in. So what automation does ultimately is it takes away those mundane tasks, and it takes away the errors that come and are introduced because of doing mundane, repeatable, easy to do tasks. And that frees up your smart people to do neat and new things. This is kind of like a repeat of what we said. So how do you automate? And this is where the real problem comes in, because most organizations, as I said, are complicated. You've got a mix of Windows and Unix and Linux and AIX and ZOS and whatever other platforms. You might be working in Azure and in Amazon and in Google. You might have your own on-premise virtualization, maybe even your own private cloud with OpenStack, or you're using Red Hat virtualization or VMware or Nutanix. You've got all kinds of different networking gear. You might be using F5 or EMC, or sorry, F5 or Cisco, or a number of different networking appliances for your different work. And so what you end up having to do is, for your DevOps, you'll bring in, say, a Puppet and someone who's have to have Ruby skills. And for Cisco, you're going to have to learn the Cisco languages and have an administrator over in that case. And for your Azure, you're going to use the Azure tools. And for Amazon, you're going to use the Amazon tools. And essentially what you end up having is this monstrosity of different tools and slices that you have to deal with to automate. And so picking an automation tool that cuts a path through this is very complicated. So you have to have certain things you'll want to consider in order to do it. And what you want to consider are some pretty simple stuff. Is, will the tool work in all or most of my platforms? Is it something I can use in more than one place? Or am I going to have to learn a whole bunch of different skills and have different people that I need to maintain and keep employed with me to do all of these different types of automations I want to do in my organization? And more than that, modern automation tools will actually work with my networking gear. Because in the past, there weren't really any really good tools for networking. There were some network management tools, but they would work for particular devices, and every single vendor or OEM of networking gear would have their own set of tools. So you'd end up with a bunch of different tools to do your management. Can I find something that will actually work across the board for my networking infrastructure? Will the tool work wherever I run workloads, whether that workload is in the cloud, whether that workload is on on-premise virtualization or some remote data center? Can I use the tool across the board? Will it provide support for the different types of hardware and software I use for my application server instances, for my all the different kinds of things? Will it work with my Microsoft infrastructure? Will it work with my AIX infrastructure? Can I use it on my ZOS box to work with IMS? Those are the things we need to know. Do I have to actually manage and control it on every single machine I'm going to use it with? Do I have to have, if I have 10,000 servers, am I going to have to manage and install an agent on every one of those 10,000 servers in order to use the product? And how much does it cost? Because that's obviously an important consideration. If I want it to scale, I don't want a tool that I buy just for my servers and then buy a different tool for my desktops just to save money. I want a tool that's going to work across the board and be cost effective and cost efficient. And one of the most important things is companies have already done automation. So even if you don't do a lot of automation, I guarantee you that in every organization I've ever been involved with, the networking guys will have a few scripts that they reuse over and over again. The DevOps guys probably have an investment in Puppet or Chef or Salt or other tools. The AIX guys are probably using Maestro or some other tool. So there is some investment already where you've done some automation. Does any other tool I bring in take advantage of that, or do I have to rewrite everything from scratch? And then finally, is the tool going to be something that's easy to understand? One of the critical problems with a lot of the existing automation tools out there is that they really demand really, that your administrators, your networking administrators, your change configuration administrators, your cloud administrators be programmers. And that's a problem because typically they're not. I want a networking guy who understands networking, understands VLAN overlays, understands how to configure between data centers and all that stuff. I don't care if they know Ruby or not, and I certainly don't want them to have to know how to do that kind of advanced stuff. If they know it, great, but I shouldn't require it, and I shouldn't have to keep on-premise a set of skills that have to deal with all of the different programming languages. I'd rather be able to leverage the skills they have in hand. But what is Red Hat's answer to that? Well, our answer to that is a product called Ansible, and it's built to solve all of those problems in mind. So the Ansible family, and we're going to talk a lot about it going forward, is really made up of three core things. First, we have what's called the Ansible engine, and that's really the command line. That's the foundation for Ansible, and I'm going to get into more detail on it. But if you write what we're going to talk about, a playbook, the thing that makes things happen in Ansible, in essence, it's the engine that runs it. Now, once you've written a whole bunch of these playbooks to do the different automation you're going to do, you'd like to be able to offer that up into a console that you can manage. That's our Ansible Tower offering. It allows you to operationalize all of the automation you build with Ansible Engine. And then if you're going to do additional networking and you want support for all of the different types of networking switches and devices that are out there with the modules, that's our Ansible networking automation, because that's really what Red Hat is about. It's about support. We use open source software that we harden and make enterprise ready, and then we provide the support for our customers so they can use it in their enterprise production ready workloads. So what is Ansible at its core? At first, it's simple. And basically, it's built on a foundation called YAML. So YAML is an English-like language we're going to look at in just a second that I can teach anybody to read in about 5 minutes, and I can teach any administrator who has domain knowledge how to write in about 15 minutes. That doesn't mean that Ansible can't do incredibly complicated things and have programming occur in it, but not at the administrator's level. So with Ansible, because it's open source and because it's fully extensible, I can write the really good, complicated stuff in any interpreted language I want, but the users, the operators, the administrators, the people who are going to write the playbooks to say install software or provision servers, they're going to use something called a YAML playbook. And that's an easy to understand language that essentially just lays out domain knowledge. So if the person understands their networking and their networking switches, they can write an Ansible playbook to do the things that they want to do in networking. If they know how to do DevOps, then they can write an Ansible playbook. If they know how to install a server, which is what we're going to show an example of, then they will know how to write an Ansible playbook to install a server in about 15 minutes. Well, in fact, maybe by the end of the next slide or two. and it's powerful. So because of the way that Ansible works, and because Ansible works literally through an SSH login, which we'll mention later, in effect, Ansible can be used for your entire infrastructure. And that means all of your networking devices. That means all of your on-premise infrastructure and all of your in-cloud infrastructure. It also comes with things called plugins that we'll talk about that allow you to leverage everything around the Ansible world. So there are plugins that allow Ansible to integrate with Service Desk Now, for example. So you can actually have end-to-end automation where a request ticket is created in Service Desk Now, causes something to happen in Ansible Tower, and that actually results in playbooks running in Ansible Engine, which returns those results back to Service Desk Now, all automated, all without human intervention. There are just some really powerful things you could do with Ansible for everything from a simple server deploy or a minor configuration change, all the way to, say, a complicated orchestration of deploying a new application that spans from on-premise, third-party, and into multiple clouds. And it does all of this while being agentless, without requiring that you install anything on remote servers. And because of that, if a server's up and running, you can hook into it with Ansible and start to automate or manage that server almost immediately. So what do you get with an Ansible engine, that core thing that you use? Well, you get Red Hat lockdown hardness. Basically, we make it enterprise ready from the beginning, so that you know you're getting a product that's ready to be used in a production environment. It's based on an upstream, very active community project with thousands of contributors. Just to give you an idea of how active it is, when we started doing this presentation about a year and a half ago, well, 2 years ago, there were 600 Ansible modules. There are now over 2,600 Ansible modules, and there are around, I think, 3,500 Ansible networking modules now. These are modules that are written to control or manage a specific appliance, device, or piece of software. So this is a rapidly growing environment. There are all kinds of new capabilities coming out every day for Ansible, and it's being heavily adopted. So much so that most networking companies, in fact, I think all of the networking companies of note, are now delivering modules so that Ansible can be used to automate all of your networking infrastructure. And that's huge, because now we have a tool that has buy-in not just in the normal server platforms like Linux or AIX, but also the other major side of our IT infrastructure, which is our networking, our firewalls, and all of the different things that we also have to have in our data centers in order to make them work properly. And now we can bring them all under one tool. In addition, obviously, Red Hat provides our award-winning levels of support, and we basically manage the packaging and the updates and the management of the product itself, and essentially we take care of it for you. And the cool part for Ansible Engine is it's the only product at Red Hat where the upstream project is essentially the same as our enterprise project. So how does Ansible work? Well, at its core, you see these four things. In the center is an inventory file. This is the file that you basically list all of the things you're going to manage in, and you can group them and categorize them in different ways. You can associate credentials with them, all of which can be stored in a secured way. Your inventory files can also be brought in from other places. You can bring them down from Amazon. You can bring them down from Azure. You can bring them in from VMware. There's all kinds of different powerful tools to bring in the list of things that you're going to run playbooks against to make things actually happen. And that's what the inventory file is. On top of that, you have these modules. So these are the things being developed upstream or that you can develop yourself that actually do the work. And the way an Ansible module is designed to work is as a state-based machine. So essentially, if I have a module for deploying an application, deploying applications, that module should have the ability to know that if I run that same command twice, that it will have known that it had successfully ran it before, so it won't run it again. So it gives you these powerful tools for actually running against your infrastructure without overrunning stuff against your infrastructure. And that's the stuff that makes it really work. Beside that, we have plugins for people who have devices, for example, that don't have a normal way to talk. A networking OEM might, for example, develop a plugin that knows how to talk to their particular networking appliance. I don't see it. I don't care about it. Behind the scenes, I get to use my Ansible and my Ansible modules to interact with that networking switch, and it's the plugin that the OEM wrote that actually makes it actually work. And then we interface all of this in the Ansible Engine product with that thing called the CLI, or the command line interface. So that's where I can actually, from a command prompt, issue an actual Ansible command, run a playbook, run basic Ansible commands to run code directly or commands directly in my target servers, all from the command line with Ansible. And you can see that way we interact with it is by writing these things called Ansible playbooks. And now I'll give you a lesson on writing an Ansible playbook. So this is a simple Ansible playbook. And this Ansible playbook is written in YAML, as you can see. And it's written so that this will install an Apache HTTP server, change its configuration, and then ensure it's started. And it does it in this little bit of code, most of which, or a lot of which, is just naming content. So you see this first line, name, install and start Apache. That's just what's going to show up in the log. That's all it's there for. So you know that it's at that step and it's about to start running it. Host is where we identify from the inventory file under an all tag, any server that exists under that all tag, or any host under that all tag, will actually be what this Ansible playbook is run against. So we could say web servers if we had set up a grouping in our inventory file for all of our web servers, or all of our database servers, or all of our MySQL servers if you wanted to get that finite. And by the way, in your inventory file, your groupings can be as complicated or as simple as you want. They can be hierarchical or networking related, is that things can exist in multiple tiers at the same time. And that's all we do there. The second two lines under vars is we set two variables. So I am saying I'm creating a variable called HTTP_port, and I'm assigning the number 80 to it. And I'm creating a variable called max clients, and I'm assigning the number 200 to it, because I'm going to use them later on. And then underneath that, we see this remote user. So I'm telling Ansible how I want it to log in to these remote servers to do the commands that we're asking it to do. So that's the first part of my Ansible playbook. It's very straightforward. And as you can see, it's not complicated. The main thing is you need to know what HTTP port was for when you're talking about an Apache server. That's not a programming thing. That's not a knowing about YAML thing. That's a knowing about how to install an HTTP server, which we would assume that the administrator who writes the playbook would understand how to do. Now below we have our tasks, and again, anytime you see name, it's just what's going to show up in the log. And so our first task uses the yum module, which if you're a Linux guy, so a Linux administrator, you know that's for installing packages. And so we're saying install, the package is going to be the HTTPD package, which is the Apache web server package. And we're going to, we want it to be in the latest state, so the latest release. If we want, we could set a different release number there if we wanted to install a different version of our Apache server. And so its job will be to make that happen. We don't have to tell it anything else about it. We don't have to tell, set up any other configuration. Yum knows how to go first to check to make sure it's not already installed. And if it is already installed, do nothing. And if it isn't already installed, to install it. The next thing is we're going to run the template module, and the template uses something called Genja2. I'm not going to get too technical, but essentially it's a very powerful templating tool that if you use it as a powerful way, you're missing the point. Because what we do here is in that template file, the http.j2, it would be a version of the http.conf file, and where we would put the HTTP port number, say the 8080, which is the default, we would instead put a variable called http_port. So when it hits this template, it'll do the replacements for us on the fly, and it will save the file where it needs to go for our new HTTP server install. And then the last command runs the service module, which can start and stop package, start and stop services. And we're telling it that we want the HTTPD service to be in a running mode. So what it'll do is it'll check if it's already running. It'll do nothing. And if it sees that it's not running, it will start it. So I could take this playbook and run it 10 times against the same server, and if the HTTP server's down, it'll start it. If it's not there, it'll uninstall it. If I install a different package at a different release level, it'll update it for me. If it turns out that since the last time I ran it, HTTPD has been updated, it will update and patch it for me, all with this super simple playbook. Now, I'm not saying it can't get more complicated than this, but this is the basic stuff you do, and you get more complexity by grouping simple playbooks together. So what ends up happening is you can see right from this why Ansible is considered such a powerful tool. I don't need to be a Ruby programmer to write this. I need to be a guy who knows how to install a package on my servers. If I'm a networking guy, I don't need to be a programmer. I need to be a guy who understands what the configuration settings are inside of my switches or inside of my firewalls and so on. And then I would just write a playbook that takes advantage of those settings. So to give you an idea of Ansible modules, this was taken 2 years ago. This is how many modules there were. There are now, like I said, far more than that, and it grows every day. I stop counting. And so every one of those modules does something. So we see, for example, the Red Hat subscription module would allow you to automate updating your Red Hat subscriptions and registering your servers and all the things that you would normally need to do by hand to basically renew your Red Hat subscriptions. And there are modules for all of the other types of distros, and there are modules for all different platforms, for networking, for the different cloud environments, and so on. It's an incredibly powerful and huge ecosystem. So now I've written all of these Ansible playbooks, and so I've got an administrator who wrote a bunch to do all my server installs, an administrator who wrote a bunch to do my DevOps, a DevOps guy, and I had some networking guys who wrote a bunch that allow me to automate all of my firewall rule changes. How do we actually extend it beyond the administrator? How do we get the administrator out of that loop altogether? And how do we get a handle on all of the things that are happening in our environments, including configuration drift and changes that people are making directly on servers that they're not supposed to make? Well, for that, we're going to use Ansible Tower. So this is a web application that sits on top of your Ansible playbooks and your engine that you can then set up all of these things as menus, literally service catalog items that you can click on. And you can set up a complicated workflow that includes multiple Ansible playbooks that have to run together. You can set up a workflow that's organized and orchestrated and controlled, where, for example, if someone requests, say, a new WordPress environment to be spun up, it could send a request to an administrator for approval. The administrator approves it, and then Ansible would deploy that environment and send the information back to the customer. All of that could be done in this thing called Ansible Tower, and you would be able to track everything that everybody does and requests to have done. You will be able to track what changes are happening in servers, because Ansible can also go out to servers and pull in all of their configuration information so that you can keep track of what's happening on the servers and basically manage any drifting, configuration drift that's happening in all of your environments. So it's an incredibly powerful tool. And normally what happens is organizations will start by building their automation, and the moment they start using it in production and you've got your people basically starting to share their playbooks with each other, that's a great time to introduce Ansible Tower so you can get a handle on all those automation tools that have developed internally. So if we look at how automation with Ansible Tower works, is essentially under the hood, at the bottom of all of it, you have your Ansible engine, that's what's running, but it's all built around these Ansible playbooks that then interact through Ansible Tower, or third-party tools like Service Test Now that interacts through Ansible Tower to provide you that kind of single cohesive view of your world, where your users are seeing service catalog items, your administrators are writing new capabilities with Ansible playbooks and potentially modules, and it's all offered up with a seamless web interface so that people don't understand what's happening under the hood. So on top of the Ansible Tower, we have Ansible Networking Automation. It's additional support for our Ansible engine. So if you want to do your networking with it, you can get extra support for all the different modules, for all the networking appliances and stuff. And that's growing all the time. As of this writing, when I wrote this, we had Arista EOS and Cisco. It's much larger now. The ecosystem is huge on the networking side. But basically, we're taking the onus of making sure these packages work and are supported. We work very, very hand in hand with all of the networking OEMs to make sure that Ansible is able to work with their appliances. So when you have a problem, we deal with them, we solve the problem with the OEM, so that you have a supported version of Ansible that will work with your networking infrastructure. So this would be an additional subscription add-on that you would buy on top of your Ansible engine. So what are the things you use something like Ansible for? Well, obviously, in the operations case, this is your server room. Your administrators, you're going to use it for your configuration management. You're going to use it for your operations management, starting and stopping, life cycling servers. You're going to use it for provisioning new environments, from bare metal to cloud and image and containers, including end-to-end deriving images, creating images and pushing them into the cloud. All that stuff can be automated with Ansible. You're going to include it and build it into how you continuously build and provision new environments, so that it's done on the fly, so you can do it quickly, and so that when you do it, every time you do a new server and do a new build, it's always the same as the last one you did, so you don't have to worry about why something worked one time and then didn't work the next time when it should have. And it gives you the ability to be able to keep an eye on what you're running in your environments, to lock down your environments, to manage what packages are being installed, to make sure that things are patched at the right level, to make sure that your environments are secure. In fact, ideally, once you get Ansible up and running, if you do it as efficiently as you can actually work towards what we call a rootless infrastructure, where nobody ever logs on to any of your target servers as root. They only ever go through Ansible in order to access them, which means that you never lose sight of what's happening on any of your target machines that you're actually trying to manage. And then finally, you can use Ansible to deal with complexity. So once you get into that situation, we're deploying a new application, especially your legacy multi-tier JEE applications that involve a combination of asynchronous queues and enterprise service buses and portals and multiple backend databases, and you need to deploy something that involves all of those things. You build the individual playbooks to deal with each of the components. You put them together in Ansible Tower, and you can make it a managed process that can either work together or roll back together, making everything a lot easier and everything a lot more manageable, and more importantly, everything a lot more reproducible, and I don't know what the right word for this, much easier to back out of when things do inevitably go wrong. So Ansible automation technologies you can use for all of these different things. So this is just an idea, and again, this is out of date. Since this happened, there's a lot more than just, for example, AWS and Azure modules that you can use for automating those infrastructure. There's modules for everything, and like I said, continuously live and vibrant ecosystem providing all kinds of new modules for everything you could possibly imagine. So what are the networking use cases? Well, just like for your operation centers, your networking guys are typically not programmers. They're typically, Cisco certified network technicians and so on. They know their stuff inside and out, but they're not really automation guys. And there have been some tools that are active management tools for networking with some automation capabilities, but they really couldn't span the breadth and depth of networking infrastructure that's out there. So Ansible is kind of the first tool that's come along that do that, so much so that all of the networking guys are jumping on board saying, oh yeah, we'll make it our stuff support Ansible so that people can use it. And because of that, we can now source control our networking configuration for the first time. You can actually take all of your changes that you do, put them in GitHub, put them in whatever source control you have, and now you can really manage it. Make sure that when someone applies a change, they apply it, you can actually then roll it back very, very quickly because you'd have the previous change to run to get it back to its old state. And basically, it will allow you to take control of your networking infrastructure for everything from configuration management to your centralized management, to be able to do it all from one place, to be able to provision new environments and new configurations for new appliances when they come out from one place, to making sure your networking appliances are patched and secure and set up properly, to make sure that everything's at the right level to pass any security compliance requirements that you have as an organization based on your customers and what you do, and basically dealing with complex orchestration where, for example, you're deploying a new application that's going to require internal firewall rule changes, it's going to require routing and adding changes, it's going to require external firewall rule changes. You can do that all as a single orchestrated workflow through Ansible. Oops. So just some of the networking integrations, and again, like I said, this is old. Since then, there's been literally at least, I think, 1,000 more modules added for different networking appliances and so on with Ansible. And this just gives you an idea of all the vendors who are now on board writing the plugins that make Ansible work to control their hardware. And then, of course, you can use it for your CI/CD, your DevOps infrastructure, whether it's the traditional old-fashioned way of doing it with, say, a JEE infrastructure, or whether you're trying to do new microservice deploys where you're dealing with deployments to multiple containers, to on-premise virtual environments, to in-cloud virtual environments, to container workloads like running on Kubernetes or cloud private or whatever you actually happen to do. You can use Ansible as the tie that binds. And the really cool part is we see a lot of organizations using Ansible in this way, where they'll either use Jenkins to drive Ansible to do the little tasks, or they'll use Ansible to wrap Jenkins in other parts of their infrastructure to tie together bigger tasks. And in fact, one of the cool things that we did was we built an Ansible Puppet master replacement. So you can actually put Ansible in top of your existing Puppet infrastructure, and it will take control of all of the different nodes that Puppet Master would normally manage for you. So we're trying to make it work around the infrastructure you already have, while giving you the ability to extend it across your infrastructure. And that means the ability not just to do the things, but to roll back the things that didn't actually work. And so Ansible has that capabilities, or has those capabilities for things like configuration management, your normal application deployments, your provisioning, continuous delivery, all the same stuff. And for DevOps integrations, again, not a complete list. You can see we've got the GitHub integrations that you need, your Jira stuff with Atlassian, your Jira and Confluence stuff. We've got all the other tools that you would use, for example, for doing in-test, watching what's going on in your environments with, say, New Relic or App Dynamics. I mean, there's just a lot of different things that we're now working with and that have designed their products to integrate with Ansible. So you can bring that information directly into Ansible Tower. So why would you Red Hat Ansible versus all of these other solutions that are out there? Well, Red Hat itself we use our own products. So we're not out there selling you stuff that we're not actually using. We use Ansible. It's integrated as the delivery system for most of our products now. Is built into Satellite as of 6.2. You can use Ansible in that. It's going to be the native primary one in later versions of Satellite. We have Ansible built into our CloudForms product as well. You can use Ansible to provision and deploy your OpenStack environments. So there's a lot of places that we're now using Ansible as our primary go-to. We also use that in our software development shops as one of the ways that we manage and integrate all of our different pieces for the different builds that we do. We provide for our products enterprise level support. We really are a support company. So when you talk about Red Hat, you're really talking not about a software company. We manage upstream projects, but they're open source products that you can download and use. The reason that companies buy Red Hat subscriptions is because you want that super high level enterprise grade support. And our support is different than everybody else. We're not trying to just solve your problems, although we do that as well. More importantly, we're there to help you with the product. So if you have a question about any of our products, what's the best way to do something? How do I do something? Why should I do something? You can submit those as tickets as well. And if your product you have something else that isn't supported by us that integrates with our product, we'll still provide a best effort attempt to help you solve any of the problems that even include those third-party solutions that you've integrated into what you're doing. Just to give you an idea. On top of that, we do our normal lockdown. We make sure it's enterprise ready, that the products are secure, that they're stable, and we have a really good release cycle that gives you some assurances that things aren't going to change so fast that you can't keep up and that you can't absorb those changes with our release cycle and our 10-year support cycle for the different products. And basically, Red Hat itself is one of the top contributors to all of the different open source projects that you see out there, but especially to the projects that we own and run, like Ansible. So just to give you an idea that this isn't a little thing, Ansible right now is the fastest growing product at Red Hat. We've never seen another product, and we have many very good enterprise products, but none grow as fast as Ansible, other than Red Hat Enterprise Linux itself. And there's a reason for that, because of its ease of use, because of its scalability. It really has taken a huge curve up in terms of adoption. And you can see that by taking a look at some of these enterprise companies who have now adopted Ansible as the way to automate their infrastructures. Everything from Warner Brothers to the Navy. So what is the Ansible way? So this is kind of like a put it all together. Well, the Ansible way is that we wanted something that'll work across your environments. That's cross-platform, Linux, Unix, Windows, Android. Anywhere you can have an SSH login, you can use Ansible. It's human readable. Anybody can sit down and read an Ansible playbook if they have domain knowledge about which that playbook is describing what needs to happen. So it's not something that you're going to have to spend years training your people in or spending extra dollars trying to keep only certain people like Ruby programmers around to maintain your automation. And it's when you look at Ansible, you're not looking at how things happening, you're looking at how you want it to look when it's done. So it means that an Ansible playbook defines the end state of what you want. What better documentation could you ask for? And you can, because of that, and because it's an English-like or standard language-like human language readable format, YAML, it means you can source control it, and you can use normal source control tools to manage it, like merge tools, to keep track of and monitor and see what those changes are. It has to support dynamic inventories. We know that you have different infrastructure. You have Microsoft infrastructure, you have Linux infrastructure, you have AIX infrastructure, you have your VMware, you have infrastructure up in the cloud. You need a way to pull that information all down into one place, and you don't need someone spending hours a day trying to keep the static inventory file up to date. Well, Ansible is that tool that can bring all of that dynamic inventory information into the tool on the fly, based on what you do in your organization. And Ansible plays well with others. It even works with the other products with which it competes, like Puppet, like Jenkins, like Salt or Chef or Maestro. So Ansible is kind of like that piece that can bind. It's the one ring that binds them all, I guess is the best description that we can actually use there. And because of that, it means that when we're describing stuff, and this, as you know, is a huge problem. How many times have you got a networking guy in a room with a developer in a room with an ops guy, and they're trying to explain the deployment plan? So they're putting together a deployment plan, doing the risk analysis, trying to describe what they need things to be like, and they're all talking in their own language. Well, Ansible provides that common language that they can all understand. I'm not a networking expert, but I can look at an Ansible playbook that describes changes on a Cisco firewall appliance, and I can understand what those changes are. And I know that the next time I do deploy for that same application, that's the state it's going to be in. So if it's not in that state, I know it's changed without being a networking expert. So Ansible gives us a common language. It's the YAML playbook that everybody who's involved, technical and non-technical alike, can understand what they're reading, because they're not also digging through programming stuff as well. So that means that I have a clear, concise communication path all the way from my developers and testers to the people who actually use it, including any third parties that I bring in that have to manage or run my infrastructure. And that makes a huge impact, and it's a measurable impact, and it's a noticeable impact. So it's one that we've actually measured, and that means that your teams are going to end up saving a lot more time. They're going to be a lot more effective at what they do. They're going to introduce far fewer mistakes and errors, and they're going to basically enjoy their jobs because they get to do new stuff and not grunt work. I mean, and that's really what it comes down to from that side. And from the enterprise side, it just means you're going to get things faster, better, and of better quality. So after this, if you want, we can actually send you some case studies of some organizations that have successfully done automation with Ansible. And we have case studies in most industry verticals that will show you that companies that have been very effective at it with measurable return on investment. And if you want to find out more, Ansible has got probably one of the, if not the most dynamic open source community now, with hundreds, if not thousands of contributors are constantly adding and doing new stuff. There's a ton of material out there for you to use, a ton of projects. Even if you're just doing the using of Ansible as opposed to writing modules and new stuff, there are Ansible roles out there that you can download that provide whole frameworks for managing, say, your Cisco infrastructure, or managing your Windows infrastructure, where someone's already gone through the process of writing the Ansible playbooks, doing any Ansible module augmentation that needs to be done to do anything really fancy or neat. There are people who have already gone ahead of you now that you can take advantage of to make your experience with Ansible easier and more seamless. And so, to put it all together, the recap, so to speak, Ansible is an Ansible Tower is a set of automation tools and a framework that you can use to manage your entire infrastructure, wherever it is, whatever it is. It also provides you with the pre-built modules to hide the complexity of dealing with some of the things that organizations have to deal with. And it is a widely adopted and supported open source, and it can run on any flavor of Linux, not just Red Hat Enterprise Linux. And it only has to run on one Linux server, although you can distribute it. And the way our model works with Ansible, for example, if you have 100,000 servers in different locations, you're subscribing to support for the managed nodules, not for the instances of Ansible Engine or Ansible Tower, so you can have as many as you need for your different infrastructure. And really, that's Ansible in a nutshell. So if you don't use it, what's going to happen? Well, you're going to continue doing what you're doing now. You're going to end up with lost opportunities because you can't adapt or change fast enough to the business requirements. You're going to end up with unhappy customers, of course, and of course, unhappy employees. So think about that. Think about what automation could do for you, because it's visible, it's measurable. There's all kinds of studies out there that will back up everything I've said today. If you automate, you will make an improvement in your organization. You will speed up your ability to deliver and deliver successfully every time, and you will reduce the problems and issues that you're currently dealing with. And I guess that's where we go to. Do you have any questions? And I'm going to turn it back to someone to manage the questions because I've been watching them.
Okay, thanks, Mark. That was great. So yeah, just a reminder to those of you in the audience, if you have any questions, at the bottom of the Zoom webinar screen, you should see a Q&A box, and you can type in your questions there. We've had a couple come in. I think, Mark, you've probably covered some of them already during the presentation because they came in earlier, but maybe we can just do a recap on some of them. So one question that came in was, what are the advantages of a solution that requires no agents?
So interestingly enough, the number one thing that I hear people laud about Ansible is the fact that it doesn't require agents. And the number one complaint I get about Ansible is it doesn't have agents. And it really comes down to this. If I don't have an agent, it means that any server that I can name and have access to on a network or via a plugin, I can take control of with Ansible. I can manage it and configure it. I don't have to spend time or effort managing, patching, or updating agents on all of my server and all of my device infrastructure, because Ansible is quite literally logging into that server and doing things on that server. So from a complexity issue, that provides Ansible with real advantages over virtually all of the other products. The minor disadvantage, and it is, and we're actually working on seeing what we can do around it, is it means you don't have an active agent on that server basically waiting for things to fail to notify Ansible. And you're assuming, of course, that the agent itself doesn't fail. And how do you get around that with Ansible? Well, you basically use it as a polling agent. So every now and then you go out to your servers and find out what state they're in, as opposed to waiting for that server to report back to you. But for all intents and purposes, it's that huge lack of complexity by using something like Ansible. And because of the way Ansible works, it means I can do 50 or 100 concurrent installs or configuration changes at the same time, because it'll just start multiple sessions to connect to all the different servers or devices or things it's actually going to work with to change, obviously dependent on your networking bandwidth capabilities.
Okay, great. And just a reminder also that we recorded today's presentation. We'll be sending everybody a link. A couple more questions here that came in earlier. Where do you start? Like, what's the best way to figure out what to automate when you're just starting out with IT automation?
So there are a couple of approaches here. One of the things that we like to see is get customers into a workshop. Say BossNine were to put one together to just start playing with basic Ansible playbooks. Take some free training that we can provide links for, where you go to online and actually take some courses. But basically sit down first and get the basics of Ansible, which you can pick up in about a half an hour. And then get your administrators or networking guys to start with something simple that they do every day, like a firewall rule change, or pull in the configuration information. Get your administrator guys what they do to start and stop their servers or recycle servers. And what you'll find is that you'll start writing little Ansible playbooks to do your common tasks. And you'll do it very quickly and you'll start to love them. And then once you see that, you'll start to figure out that there are the more complicated things you do. But the way that Ansible works the most effectively is to take every individual small task, figure out what you're going to do with it, make the Ansible playbook for it, and then what over time will happen is you'll start to link those playbooks together to make a much more complicated set of activities that perform the real things you do, like deploying and changing configuration on servers. But it's the start with the day-to-day repeatable activities that you spend the most time on, because it's kind of like that 90-10. Those are the things you spend 90% of your time will be the things that will produce the most return on investment to begin with, in terms of reusability and removing the administrator quickly out of that role and basically making it a hands-free so-called automation. So you'll get a return on investment much faster doing it that way.
Okay, great. And another question just came in about, well, came in earlier. Why would I use automation solution like Ansible when I can simply write scripts? And I think that you covered a lot of this in your presentation, but just want to make sure that the person who asked it got their answer.
So imagine you write a bash script. That's administrator A on Linux. Okay, so that's great. Now administrator B has been told to deploy the same server. How's he going to know about those scripts? Or administrator C, a networking guy comes in and doesn't know bash scripts, and he's now responsible because the first administrator left. Or I'm switching from AIX to Linux. Now my skills don't exactly translate. They mostly translate. How am I going to do it? So Ansible provides a single way to do everything. It could include writing a bash script, and you certainly could include that as part of your solution for your Linux servers, but are you going to write a bash script on your Windows servers? So now I got to have another set of skills over there. You want something that simplifies it and provides a wrapper around all that complexity. So can you automate with a bash script? Yes. But once you've done that, what do you do with it? And that's where Ansible can come in. You can actually use Ansible to call that bash script. Ansible itself regularly uses bash scripts for some of the things that we do on servers. But for all intents and purposes, you have a single place to go to, a single set of tools to run, and a single way to manage all of it, however you've implemented it under the hood, whether it's with Ansible or with the native tools that are available. And there will be things for which there are no modules. And you can write a module for it yourself, or to short term, you can actually just write bash scripts or actually do raw directly into a shell with Ansible. It'll do that as well. So think bigger.
Right. We've got one last question here, I think, before we get to the top of the hour. Are there any limitations to using Ansible in a multi-vendor IT infrastructure?
By multi-vendor, you're talking multi-tenanted or multi-vendor as in, I'm not sure I understand.
Well, that was the question. So multi-vendor IT infrastructure.
So when many different vendors in that organization?
Yeah, I think so.
Well, the customer, someone's paying for the node. So whatever that, if every vendor provides solutions, modules, then absolutely not. In fact, Ansible is very happy to play in an environment where a customer has multiple vendors providing different solutions, because each of those things can be managed with Ansible. If you're talking about multi-tenanted, where you basically want to have different infrastructure managed by different vendors, say they're managed different, you could set up multiple, literally multiple tower environments, and have each tower environment manage the set of resources that a vendor is actually managing, and not the rest of the resources, but it would still be all part of your Ansible infrastructure. I'm assuming that's what's being asked. I apologize if I misinterpreted it.
Okay, I think that's it for questions. We're going to wrap it up, I think. Thank you very much, gentlemen. Thank you very much for that presentation, Mark, and thanks for joining us, Mike and Joe, for this presentation on automating your IT, presented by BossNine Technologies. As I mentioned, we recorded today's presentation. We'll be sending you a link within the next 24 hours. And with that, thank you for joining us once again, and we look forward to seeing you at a future BossNine or Red Hat event. Thank you.